Hi, we're on top of Salesforce Tower in San Francisco, California, the tallest building west of the Mississippi. People from all over the country come to Salesforce Tower to work on cloud computing and business solutions. But we're here today to do some Carpool chemistry. Today, we're going to learn how to do acid-base titration calculations. Let's say, for example, a student finds that a 22.6 milliliter of 0.108 molar hydrochloric acid is required to neutralize a 20 milliliter sample of potassium hydroxide. What is the molarity of KOH based on these parameters? Well, the first thing, of course, that we want to do is list the items that we are given, so we would know what we have available to us, and then afterwards we'll write down what we need to find so we know where we're going to need to go. The first item that's given to us is volume of the HCl is equal to 22.6 milliliters. Now we're working with molarities, and we know that volume in molarity is expressed in liters, so let's just automatically convert that to liters times 1 liter for every 1,000 milliliters is equal to 0.0226 liters. The next item that's given to us is the concentration of hydrochloric acid, and that is concentration of HCl is equal to 0.108. Now instead of writing that capital M there, I'm going to put that as moles of HCl per liter. The next item is given as 20 milliliters of KOH. So volume of the KOH solution is equal to 20.0 milliliters, and once again we want to convert that to liters times 1 liter for every 1,000 milliliters, and that is 0.020 liters of KOH. And let me label this one up over here too, of HCl. Okay? And I think those are all the numbers that are given to us. There is one thing that we must realize in this problem, and that is during a titration, we're neutralizing our acid and base, and at the end point of titration, the moles of HCl is equal to the moles of KOH. They react on a 1-to-1 ratio, 1 hydrogen and 1 OH in the formula for KOH. Knowing this, let's go ahead and write down what we need to find. We want to find the molarity of KOH. Molarity of KOH. Now, what do we mean by molarity? What is the formula for molarity? Molarity of KOH is going to be equal to the moles of KOH per liters of KOH solution. Well, do we know the moles of KOH over here? Well, no, we don't. But do we know the liters of KOH solution? And yes, we do. It's 0.020 liters. I'm going to put a check mark by that for right now. So if we just knew the moles of KOH, we should be able to find the molarity just by dividing that number by our liters of KOH. So in order to find the moles of KOH, let's set up some dimensional analysis. Want is equal to have times factors. Underneath want, what do we want? In this case, we want moles of KOH is equal to, well, what do we have? What's our starting point? What are these moles of KOH depend on? If we let's given to us, it's 0.022 0.226 liters of HCl is the quantity that's given to us. We know that this number over here is not a half because this looks more like a factor that relates two things together. And so let's start off with 0.0226 liters of HCl. We need to somehow relate liters of HCl to moles of KOH. Do we have a factor that relates amounts of HCl to amounts of KOH? Well, if we look over here, we know at the end point, the moles of HCl is equal to the moles of KOH. In other words, there is 1 mole of HCl for every 1 mole of KOH. But this is in moles. What we have over here is liters of HCl, not moles of HCl. Can we convert liters of HCl to moles of HCl first? We sure can, using this factor right over here. Times 0.108 moles of HCl for every 1 liter of HCl solution. Our liters cancel out. Now that we know the moles of HCl, we can find the moles of KOH using this relationship right over here. And I think we're going to have to flip this over to get our moles of HCl on the bottom to cancel out. And our 1 mole of KOH on the top. And now we have moles of KOH, which is what we're looking for. Let's go ahead and put our equal sign there. Let's go ahead and crunch this number on our calculator. 0.0226 times 0.108, and I got 2.44 times 10 to the minus third, which is simply 0.00244 moles of KOH. Well, now that we know the moles of KOH, we can go ahead and put it into this equation right over here. And that's equal to 0.00244 moles of KOH per, and how many liters of KOH solution is given to us? It's in 0.020 liters of KOH. And if we crunch that number, 0.00244 divided by 0.02, and you come up with 0.122 moles KOH per liter of KOH solution. And that's how you calculate the molarity of a base in an acid-base titration. From the top of Salesforce Tower in San Francisco, California, this is Carpool Chemistry. Thanks for watching.